Dr. Justin Blessinger is a professor of English and director at AdapT Lab for Accessibility Through Tech at DSU. The AdapT Lab is devoted to removing barriers that impede people from engaging fully in their world. This last sentence, you got me. So, Dr. Justin, please tell us what your lab does and where you're located.
The AdapT Lab is brand new, just opened in our new facilities at any rate, although I suppose our pedigree goes back to about 2016 was our first project as such, though we didn't have the name just yet. That line about engaging more fully with our world and that we're devoted to removing barriers, and we use technology to do that. Of course, there are many ways to do that, but we're a very technology-driven university here at Dakota State, which is in Madison, South Dakota. I'm surrounded by labs devoted to internet security, Internet of Things, Red Hat, and defensive and offensive hacking. There's a smart home facility sort of built into the building behind me where they monitor electrical usage and partner with the local electrical company on using smart devices to reduce our footprint in terms of energy use in the world. So what we're really devoted to is this idea that there are many things that get in the way of our full participation in life, and that is regardless of our age, regardless of our sex, regardless of our race. It's true what the AARP has said, that all people will endure a disability of some form in their life, and especially, of course, if you should age long enough. And so when we start thinking more broadly about what we currently call disability, whether short-term or long-term, and we think more broadly about what we call health, as mental health advocates will often tell you, right? We need to think more broadly about how we think of our health as well. We find that there are a great number of things that at different seasons in our life interfere and become an obstacle where before they weren't. The AdapT Lab really got its start from a series of conversations. A blind friend of mine and I were going to visit another friend who works with me in the lab, Professor Chris Olson, also here at DSU. Professor Olson has tetraplegia, a form of quadriplegia from an auto accident about 18 years ago. And my blind friend and I were looking for Chris's office. And as we entered the building, my blind friend said, I have not been to his office before, have you? I said I hadn't either, but I looked quickly to my left and there was a sliding letterboard, and we knew immediately, oh, okay, he's on the second floor, on the first floor, and the number. My blind friend asked how I knew that. And I had to say, well, there's a sliding letterboard there. And we had a conversation then about how few things actually are imprinted with Braille. You know, restroom doors, but all the other doors don't necessarily need to be. So you end up wandering around feeling every door until you find the restroom. And that was a real eye-opener for me to understand better how much of the world is invisible or that needs to be sought out through much more laborious means. And so we started working on a project that used Bluetooth technology to broadcast just things like the rest of us would find out through casual signage. So especially directory information, restroom location of vending machines, and maybe some emergency services like where is the fire extinguisher and so on. And the hope was that this would be useful regardless of ability or disability. Who doesn't want to know where the restrooms are relative to them without having to ask, right? Or where the vending machines are, for that matter.
Can I interject here just for a second, just to make sure that I understand properly? Is that the same of that amazing thing that I found out is that they've made a blind walking stick? It talks to you. Is that the same as what you're describing to me as the Bluetooth technology?
Researchers working on different helps for the visually impaired. And ours does not use any kind of a cane or anything. It just uses your smartphone. And what it's really doing is just telling you context. What's near you and what are those services and what do they mean? You know, so for example, in a courthouse, you might see a sign on the wall that says Department of Equalization. Now, what on earth does that mean, right? It's a very unhelpful title, you know, born from 150 years ago or more, taxation language that isn't something that most of us speak. And so if we can broadcast that there are 10 things near you And if you want to know more through your phone, then you can click on any of those, and then of course learn more, learn what the Department of Equalization is, learn better turn-by-turn directions. But we're not doing navigation, strictly speaking. We'll leave that to others. We find that most of our friends who have visual impairment are pretty capable at navigating. It's the information that they often lack. And so our first project, the GoTo app, was designed to simply broadcast context specific information to anyone, sighted or not. And from there, we've simply grown. And so we do a great number of projects. I'd like to show you a few as I show you around my section of what's called the Madison Cyber Labs, or MAD Labs in local parlance. But my section here is between, as I said, a couple of the higher security and more technologically sophisticated kinds of labs. And ours is a little bit more devoted to um, objects in the real world, you might say. We don't do as much coding, though we do develop apps to speak to some of our devices that we work on, that sort of thing. So one of the more popular ones is just, this is not our design, but we've been working on modifying the design. This is a wheelchair, and we've worked on 3D printing some gears that can turn it into a rowable wheelchair. So with the right parts, only about $150 worth of parts, I suppose, and some patience with a 3D printer, because some of these parts take hours to print. But we can create a ratcheting gear setup that allows a person to row the wheelchair rather than reach down and grab. So if, of course, hand strength is an issue, it's just a different way of making a manually powered wheelchair go. And of course, by using a lever, it uses different muscles and sometimes magnifies the kinds of muscles and muscle groups that you might have or have developed well. Another project that we've worked on is a modification to the Xbox gaming system. So down here, I'll zoom in here in just a sec, but we've been working with Microsoft, who provided a couple of the core unit, which is their accessibility controller, their accessible controller. And from there, you can jack in any number of devices, mostly devices that just send an on-off kind of signal. But there are a few potentiometer inputs on these devices as well. And so by working with Professor Olson, we've been working on a farming simulator game that he really enjoys playing. What's interesting is that when he first played this on the Xbox, he told me he had not played a console game in over 18 years since his accident. Now, he had played games on the PC because he has some limited arm movement and he types with sticks, and that's how he's been able to put together an extremely successful career as a computer science professor here. But obviously, still, there are things that get in the way. And so I'll show you the device here briefly. You can see that most of those are just off-the-shelf switches, but we did create a box that has the joystick input that's a lot more comfortable for him to use. And then what are called latching switches that stay down once pressed. So if he wants the tractor to just keep going while he uses his hands to change inputs or change attachments for the tractor or something like that, he's able to. Now, it's not critical that we are able to make the farming simulator game accessible, but what is critical is that more and more we're seeing fly-by-wire technologies, drone controlled, artificial intelligence controlled kinds of technologies in agriculture. But these need pilots who can check and can avoid trouble remotely and can navigate a vehicle back to a safe location if it needs, and those sorts of things. So there are actually careers that are emerging in agriculture that are more about remote control of these kinds of things. And of course, this has applications beyond agriculture as well. Once we have people better equipped to input their intentions, whether through a keyboard or through a joystick, there's a number of career opportunities there and workforce development kinds of things that change as well. I know that your work with the Kindness Project, and I've got the name wrong there, but you'll have some interest in the little electric cars that you see behind me in a number of locations throughout the lab. There are 4 of them in our lab right now. These are all part of what's called the Go Baby Go program. The Go Baby Go program is a partnership between DSU and, well, it's a national program, but our local iteration of it is a partnership between a large care facility in Sioux Falls, which is about 50 miles south of us, and the AdapT lab here at DSU. And what we do is modify electric toy cars, you might say, the kind that children can ride in, though. And we make them more like accessibility machines. That is, we work with therapists to know what the specific abilities and maybe limitations of a given child might be. And then we do things like modify them for greater comfort, security, additional safety belts, and things like that. We move the accelerator to different locations. So I'll zoom in a little bit on one of those. So you can see we've moved the accelerator up to a simple switch on this one, whereas over here, it's more of a large red button with the steering attached to a stick of sorts. This allows children who don't have maybe leg control to still be able to get the accelerator to go and to be able to steer all in one. Most powered wheelchairs are designed for children of a certain weight and height. It's a weight and height that most children wouldn't attain until at least 3 years old. So this allows children to move into a mobility device much earlier at no cost to the families, but at very little cost to the donors as well. You know, we can pick up the machines for $200 for some of them.
And may I ask you the question? So Go Baby Go is national project
Yes,
exactly on the
and it has
mobility.
chapters throughout the nation.
Okay.
And we are the only one in, I think, at least 3 states. So in Minnesota and both Dakotas, probably in Nebraska as well. So it might be, no, they did some training down in Omaha. So there must be one in Nebraska.
Okay. Thank you.
Right. And so what DSU can do, because of our um, ability with all things tech, is that I've put together a team of students who travel with me when we modify the cars. And they've started working on an app that speaks to a Bluetooth device that cuts power to the car if it should get too far away from a given smartphone. So if mom or dad are a little worried about their little one as they're exploring the world in their new car, then they can set it up so that if the child leaves a 50-foot radius from mom's phone, the car simply turns off. So its default position is actually off. And if it's close enough to mom's phone or dad's phone, then it turns on. And so there's, of course, also just the ability for mom or dad to simply turn it off through the app as well. So if you see that they're heading in a direction or they're not listening just now, you can shut them down, which maybe the children won't necessarily appreciate, but we sure think the parents will appreciate. We've also worked with one of the other labs here, the Cyber lab, which is devoted to increasing participation of women and girls in tech fields, especially the STEM fields. And they have a number of camps that they are able to host here at DSU, bringing in girls of different ages, but there's one in particular this summer for middle school girls, all the way up to, I think, at least early high school. And we will be working with them this summer to modify the silver Mercedes ones that you just saw behind me, because those are 2-seaters. And I love that when I pitched the idea to the Cyber lab, just a few labs down from me, one of the things that really lit them up was just pointing out that so many of the cars that we've done to date and that the program often does are single-seater cars. Now, once you have one of these, every kid now covets what you've got. And, you know, that's not something that children with disabilities get to say very often, right? That on the playground now, everybody wants to be their friend. And so it's actually a way of increasing social connections in addition to giving them greater mobility. Early researchers thought were kind of afraid of putting children in mobility devices too early, thinking that it would maybe stunt their progress on their physical development. But what we found and what the research is now bearing out is quite the contrary. Now a little one can follow, they say, their big brother into the other room, and they know what kind of trouble big brother's been getting into in there, and it's fun, and they want to go along in the future. So their world just got a little bit bigger, and they're that much more curious. So now they're much more engaged in their world than they had been before. And there are also ways that we can use, the therapists have worked with us to point to certain ways that we can use the cars to improve some of their, say, core strength issues and things like that. So for example, we can put the accelerator button behind the head. So if they're working on neck strength to make it go, you've got to go through that exercise and so on. So a number of really interesting possibilities there with that project. We also work on remote access to things like elevators and those push button silver push button accessibility doors that we still see all over. We're trying to make those open based on proximity. So a person with a powered chair or a disability of any type, or somebody who just doesn't want to have to deal with the door, prefers, they can have the app on their phone that broadcasts their intention to have doors opened or elevators called on their behalf. And of course, you can opt out by location specific. So if my elevator or the elevator in the building near my office would be a problem because it would be being called all day long, and no one in the building would be very happy with me if I was constantly summoning the elevator just by my proximity. So we had to come up with some sort of logic on that kind of a project. But it's one of those that's just sort of in progress right now. But yeah, a number of different projects here at the AdapT Lab. I know I'm forgetting several right now, but that gives you a good taste of the kinds of things that we do.
Wow, it's mind-boggling and so much fun because I am a big advocate of technology and children. So to me, this is like a candy store. I'm
Yeah.
going to ask you a question that I'm sure any Rotarian would think by now is how do you guys survive financially? Who are your contributors?
Right. Well, uh, the new location has really been a big help in that regard. Because when we have dedicated facilities, and now we're working on tooling, which we've just received some funding for with regard to tooling. So that makes us so much more able to make the argument, especially to federal agencies. So a little known entity in the federal government underneath Health and Human Services is the Administration for Community Living, which I really like that term too because it has already demonstrated that awareness that we're talking about the elderly, we're talking about people with maybe disabilities or accessibility issues. It's a bigger tent than some of the language suggests otherwise. But the Administration for Community Living has another sub-entity called NIDLR. And NIDLR is a long acronym that I won't bore you with, but they're devoted specifically to using technology in pursuit of better accessibility. And that's been I guess you might say, our fishing hole at this point. We actually haven't landed a grant from them just yet, though we've got a couple out, and we'll know near the end of the year with regard to those projects. One of those is that elevator project and door opening project that I spoke about. So we've got some feelers out with them. Now we also have some grants that I mentioned for paying for our tooling. So one of the things we need to be able to do in the AdapT Lab is fabrication. That is to be able to take an idea that somebody else out there maybe came up with, like those gears for the chair, and to be able to say, they had created a chair that was using bars that were still down low, and what we wanted to do is to bring those bars up, bend them across the lap some, and make it more like rowing a boat, and really change the muscle group that was involved in making and propelling that chair forward. And so we did some modifications to it, but we started with an open source project that was graciously shared. The more we can do that, the better. But if we've got access to good fabrication kinds of things, so laser cutting devices, there's a new, much more affordable style of laser cutter. If you give up on the etching side that many laser cutters can do, and just want something that can cut and can cut with extremely high accuracy and speed, there's a new device that marries a plasma cutter to a CNC machine, computer controlled. And so what it is a large table that the plasma cutter head gets moved around on it with a system of gears and cuts out any shape you can imagine. So from sheet goods, then, if we want to cut out metal gears, for example, or if we want to cut out brackets that can help us mount things to wheelchairs or other devices, that gives us the ability to speed up the prototyping process by leaps and bounds. And so those are two technologies that, while there's 3D printing definitely already in many places, this is a particularly good one that can do two heads, two types of filament at once, one of which can be water soluble. So the benefit of that is that there's a lot of support construction in 3D printing, and also internal components that if you make those out of water soluble filament, you can throw the whole completed printout into a tub of water, and then the interior portions melt away, and now you have the access to that internal for passing wires through, or for maybe hydraulic kinds of components and things of that ilk. So, and then some of the new materials that the newest 3D printers can handle have Teflon infused, fiberglass infused, so much stronger. And of course, that gives us a lot more reach as well in terms of what we might think about and how we might approach a given accessibility problem.
How do they find out that you exist and that we can find relief for our loved ones?
Um, well, my goodness, we don't have a good outreach program at this point. Um, we're two dedicated researchers and then a team of students. And I have to say, DSU attracts some of the very best when it comes to anything cyber. And so that's been one of the most rich blessings, I suppose, in our work. That when I need someone who can do far better code work or app development than what I'm equipped to do, um, I need only knock on the door of the College of Computing and say, who would you recommend? And often enough, the students come to us. They know what we're doing, they care a great deal about it, and they want to be a part of something that has such immediate benefit and not something that's so necessarily dedicated to the monetary. Not that I'm bashing making a good living on what they're doing, but that some of them just come to us looking actively for projects that are outside the realm of selling the app that they're creating, and instead making a difference in their world. So one thing that we really could work better on would be better outreach for our lab. We'll say that we're, because of our smaller size, though, we are devoted specifically to one project or 5 projects at a time, um, and a little less than I'd like in terms of meeting with people, because the best ideas always have come. Every single one of them has come from a conversation with someone who's just willing to be really frank about what annoys them in the world. As I said, Professor Olson's been fantastic in that regard, because he'll show me, look, when I need to use this elevator, for example, I need to position my powered chair in a really odd angle just to hit that button. And then, of course, because I'm in an odd angle, once the door opens, I'm in a mad rush to get myself out of that odd angle and then into the elevator. And then, of course, another thing a lot of people don't know is that elevators are often grandfathered in under older ADA guidelines. You don't have to upgrade an elevator, they're extremely expensive. So if you're in a rush, you might just pull straight on into an older elevator. Well, that would be a bad idea, because the doors would close behind you. And if it's an older elevator, often you don't have room to turn around. So the door is now behind you and the controls are now behind you. And so Professor Olson described to me a situation where once upon a time he found himself at another university and managed to get himself stuck in an elevator and had to call, thankfully, because he had his phone, had to call for help. And he was in there for a while because it wasn't a heavily used elevator. So those are things that those of us who don't use chairs, we just don't think about very often. We don't think about the tricky latch on a bathroom door. And we don't think about an elevator's positioning for its buttons. But those are part of everyday navigation for folks who have disabilities. And one of the things that I actually breathe a sigh of relief. It's both frustrating and it's a blessing that so many of the projects we work on are solvable, really solvable. You just need to get the right 3 or 4 people with some expertise in the room. And that's what's not been happening, right? We haven't asked the right people to just get in the room and say, how could we make this easier? How could we make this better? They aren't necessarily issues that are life transforming, but they are issues that make your day better and waste 10 minutes fewer, perhaps, of your life. And think about how frustrated we get because 10 minutes wasted in our day. Well, people with disabilities are no different. They're frustrated by time wasted just like you and I. And so it's a really powerful thing when we get to have those conversations, find out something that is impeding your ability to really participate, and let's set to work on that.
So my question is something that I always think about because I work a lot with the elderly, children too, but the elderly too. And I, as you know, we have more and more Alzheimer's and dementia
Sure.
amongst us. And so I'm always, thinking, could I put an Apple Watch or any watch, technology watch on the wrist of someone, and
Mhm.
would it then be able to say, could they then say, get me home? And would it then guide,
Yes.
maybe I'm totally far-fetched here,
one of the projects that we've got sort of in the woodwork right now has to do with something along those lines.
Okay.
We have a partner entity in town called Valiant Living, and they provide care for adults with disabilities in um, independent living situations and in group home situations and things like that. And one of the proposals that we put together, we are seeking funding for, but is really to use devices that something like the Google Hub, which has a fairly large screen and is a artificial intelligence device that we can use based on cues that would be drawn from the individual's individualized improvement plan, which is sort of like an education plan, often for adults. And so, for example, if you had an individual whose goal was to independently make their favorite meal of mac and cheese, if you knew, okay, the mac and cheese is always going to be located in a given cupboard, we put a simple sensor on that cupboard. When that cupboard is opened, the Google Hub knows to prompt, hey, it looks like you might be thinking about making mac and cheese today. Do you want to go through the steps? And if yes, then we proceed. If no, otherwise. And then, of course, putting a sensor on the stove as well. So we know if it's on or not. And then if it gets left on, you prompt to turn it off. If they don't turn it off, then we send a text message to a caregiver proximate and have them come in and walk through the process with the individual to turn it off so that they're working on those independent living skills. This, of course, has applications that I'm sure you're seeing already for those with dementia, with Alzheimer's, who need often just a prompt, just a reminder
They
in order to
always
get back
need
on
a
track.
reminder. Yeah. It would honestly save an enormous amount of people actually going to nursing homes,
Mhm.
because uh, the crazy part in me saying this is that they can actually live at home if they could just remember to eat, and if they just could remember to take their meds. Because I have seen so many where, you create the meds really well, in trays, and this is this week and next, and they're really good at that.
Yep.
They're amazing if you just help them that little bit, but you don't know how to remind them except by phone. But
Yes.
that takes a lot of effort, and that takes a lot of effort for the caregiver,
Mhm.
especially if you have 10 or 20, or do you see what I mean? So
Yes, I
what
do.
you're describing is like a godsend for them, but
Yeah.
for us too, and not to have them yet in a nursing home when they're still so capable.
Yep. Aging in place, right? That's a critical component, especially as we're seeing increasing shortages in the caregiver population, right? There's fewer and fewer people taking care of more and more elderly folks. And so, with that kind of challenge, we have to use technology better. It's not the only solution, of course, and for us to think otherwise is to harm people who are trying to age in place, right? We need people in those industries and good people who care deeply about caring for others, but they need help, and that's where technology really is properly used. That's the sort of ethic that we work by. We want to be able to talk to caregivers as well. We're not merely talking to people with disabilities, but we're also talking to the caregiving population too to say what frustrates you. So we're working on a magnetic charging cord that just snaps too, so that when we watched a number of caregivers down at a place in Sioux Falls, and we saw them unplugging and plugging in a great number of cords when they moved certain individuals who had touch screen input in order to communicate, that sort of thing. Those are very power intensive devices. And so they don't draw power from the chair, since that would draw the chair's power down. So they plug in all the time. And what we've been working on are coming up with ways to make those connect magnetically. So as long as you're parking in the same place. So again, my partner Chris Olson in the lab here, um, we're working on one just at his primary desk in the computer science office, so that when he pulls up to do work for the day, he's charging, because why not, right? So those kinds of things facilitate um, the job, or help those in the caregiving position do their job just a little bit faster and a little bit more reliably. And of course, when you're done with that location, when you back away, the magnet just lets go, and you don't have to worry about disconnecting. Whoever designed the charge ports on powered chairs, I would like a few minutes alone with that person. I think they used the parts left over behind an audio technology store. It's a microphone jack that's being used. Yeah. It's a microphone jack. Now, I'm not sure if that's what the term was when they invented, but that's where you see these being used. And it's out on the very tip of beyond the joystick even, of the chair. So even if you have full dexterity in your hands, it's a circular charge socket. So guess how many times you get to rotate it till you finally, were to get it to land. You think USB is a nuisance with the one side up. 360 degrees of rotation is even more frustrating. And it's out in a very inaccessible location, proximate to the chair. So a caregiver is often the person who plugs the charge cord in, even if the individual in the chair could otherwise do it, if they could see it, but they put it in a really problematic location.
My last question to you is worldwide for a second. Developed, underdeveloped countries, it doesn't matter to me. So, um, these projects that you have, once they're viable, once they're tested, there's a prototype, it works,
Mhm.
you have proof, literally. Is
Yeah.
there, or am I just totally crazy here? Is there like a sort of mass production, and does it go out to people in Europe and Africa and Asia, or not at all?
Yeah. So it's a great question, and it's a great question that universities have to do a better job of answering. The building that I'm in
Mhm.
is part of the solution. The Madison Cyber Labs is a sort of new way of thinking about how we work on research in the university environment. And what I mean by that is that it accelerates the process of getting the ideas out of the research world and into the commercial world. There are a lot of old governance issues that impede faculty from stepping outside of their teaching and working on projects like this one, or like the AdapT Lab or any of these kinds of things, especially if there's any kind of a commercial application beyond that. There's a long, drawn-out process for intellectual property negotiations. If we can streamline that process, and a building like this really facilitates that, because this is not a building where um, just anyone can come. We're in a secure facility here, and only students that have gone through a certain vetting process are able to work with us in here. But this means that there's a great deal of sharing of ideas. Very few walls between the labs that aren't devoted to high banking security or forensics security is another issue. Those would have walls, but we have a great deal of cross pollination that happens in a facility like this. And then we're also working on sort of reinventing some of the policies, because we're now in a new space between the university, or the traditional university, and the corporate world. And when we have corporate partners who come in and maybe sponsor some of our research, we can have that conversation about intellectual property up front. How are we going to deal with this? And then it gets immediately into the corporate partner's hand as soon as we've gotten it approved through our funding agencies and through human subjects committees, things like that. So once it's ready to go, the professor doesn't also have to be a businessman, doesn't also have to be that's been the real impediment, especially for smaller universities. The university would say, great, good idea, now you should start a business so that you can move that to. Okay, I mean, that's one way to do it, and it's not a terrible way to do it. Some people have been very successful that way, but as an English professor, I didn't really want to also become a CEO of a small company. And there are so many other hats that I'm wearing just by virtue of being an English professor who works on accessible technology. That's another one. It maybe is a bridge too far. So the supports that we get to break down those kinds of barriers make an enormous difference. Finally, most of our proposals that we put together, and I think this is relatively unique to our lab. We always mention what we think our cost per unit at the prototype stage will be when we get it out the door. That is, so for example, if it's under $50 to get it out the door for us in prototype stage, any reasonable person knows that because of economies of scale, you're going to drive that price way down when you start ramping up a manufacturing process there. Therefore, the device should be extremely affordable to the end user. And so we're we're keeping our eye very close on the cost of the units that we build, the software that we create, the app software that we create. I believe for everything we've made so far has been free. That is, if it's for an end user, especially an end user who has a disability or provides for people and a caregiving, we're not charging for that. That is not our model for how we work. And so, the facility that has the elevators and so on, so if it's a university or a public building or something, we want them to adopt our solutions. We want them to implement them. If it costs them only $100 to make an elevator smart, then why wouldn't they do that? I mean, when you look at what it cost back when the ADA rolled out, and the cost of retrofitting elevators to make things physically accessible, buildings were brought down sometimes because it was cheaper to build new buildings than to face that hard reality. We're talking about a few $100s. And so we put that into everything that we propose because we think that the funding agencies, if they're not currently paying attention to that, we really think they need to be. Because, as you said, it's not just a United States issue. This is an international issue, and if we can keep those prices down, and I know that $100 is a major investment in some parts of the world yet, but this is a device that we think, if it were entirely designated medical, it's going to get well into the thousands. So if we can keep it in a more of a commercial space and less the medical, there are some things that are unavoidably medical, right? They have to have those extra layers of safety on them. But for those things that we can keep from necessarily becoming medical, we are able to keep the price down, and think with that always as one of our targets. Um, I do need to mention that there's a project out there that you may know about because it's actually probably 15 years old by now, that takes a lawn chair, plastic lawn chair, the ones that are a single piece of plastic that are plastic injection molding, that's how they're created. And they take children's bicycle tires, and then a few other parts, and they make wheelchairs out of them. And it's a $10 wheelchair. That was their target. And they can fill a crate up, a shipping container up with 1,000 of those things, and get them to a place that hasn't had good access. And it's much more of an all-terrain because of the bicycle tires kind of wheelchair, and a great way to make a significant difference. I recall the name of the charity that structured that, but I'm sure if you Googled with just that information, I'm sure you're gonna find it. I think they called it the $10 wheelchair, so that would probably be the
That's
first place I'd look.
That's absolutely awesome because I think from everything you said in this entire program, I think for us Rotarians, it gives us a possibility to understand more what is out there.
Yeah,
Because that Rotary is awesome in supporting causes all over the world, but if we don't know about them, that they're even in creation, then we can't even get them to the right people. So often, just having the knowledge is something amazing for Rotarians to have. So I thank you for that,
indeed.
and I thank you very much for doing this.